So this is a continuation of lesson 9.3, and this is going to be a problems from the homework. So we're going to practice a few of those because some of them, as I look at them, are not in the examples there. I hate it when they do that. So let's go ahead and look at number 60 here. We've got the cubed root of 5x over 4y. Alright, let's go ahead and split that up to cubed root of 5x over the cubed root of 4y. Alright, so what we're going to do here is we're going to try to figure out what we can do to get rid of this radical down here. So what I'm going to do is I'm going to change the, let's do it down here, cubed root of 5x, and I'm going to change the 4 to a 2 squared y. Alright, so because of this 3 here, I need that to be a 3, and I need that to be a 3. So to get this to be a 3, if I put a 2 to the first power there, that'll give me a 3, and if I put a y squared, this y squared plus this 1 here will give me a 3. So I'm going to multiply the top and bottom by the cubed root of that. And that's how you decide what you're going to multiply top and bottom by. So this gives me the cubed root of 10xy squared over just our, over 2y. Okay, so notice I got 2y because see the exponents here and the sign here all disappeared once we multiplied these two together. So just remember that. It doesn't matter what you multiply these by, when all is said and done, all of the exponents and all the radicals will go away, and you'll just be left with that. Alright, so let's try 62. We got the 4th root of 8 over 9x cubed. Okay, so we're going to do the 4th root of 8 over, well, let's make that a better 8. Oh my goodness. Over, so that's the 4th root, and this is the 4th root of 9x cubed. Alright, let's change the 9. So let's change that to 4th root of 3 squared x cubed. Alright, now I want this 2 to be a 4 and I want the 3 to be a 4 so that I can cancel with that. So I'm going to multiply top and bottom by the 4th root of, to make that a 4, that has to be, I have to multiply it by, I have to add another 2 to it. So I've got 3 squared, and to get this to be a 4, I do that. So when I do this, 2 plus 2 equals this 4, 3 plus 1 equals 4. So that's how I know which one to use. Alright, so when that's all said and done, multiply those, so I get the 4th root of 8 times 9 over 3x. Okay, let's look at 66. 50x squared y cubed over 3z. Let's split them up. Okay, let's see which one I'm doing here. Alright, so let's go ahead and simplify this. Well, let's go ahead and multiply top and bottom by 3 square root of 3z. When we have a square root, it makes it real easy, and we get 150 x squared y cubed z over 3z. Alright, that's still in a radical sign. So the bottom is done. That's all we can do with that 3z. But the top, we're going to go ahead and simplify. So let's move this up. And what we're going to do, I need a different color here. Let's go with yellow. I'm going to take my 150 and I'm going to write it as 5 times 5 times 3 times 2. So what is that? That's 150. X squared y cubed z over 3z. Alright, and then let's take our 5 and write it as 5 squared. And remember, this is a 2. How many times does that go into that? 1 time. So 1 5 pulls out. Alright, the 3 and the 2 don't have any exponents, so they stay in there. We can just multiply them together. So we've just done all of that. How many times does 2 go into 2? Once, with none left over. 2 goes into 3 once, with 1 left over. And 2 goes into, there's no exponent on the z, so that goes like that. And we put a 3z there, and we get that for our answer. So that was number 66, but for some reason, okay, yeah, that was number 66. I thought I had done something wrong there. Alright, we're going to look at some that they didn't even allude to in the instructions down with number 71 on down, where they have these weird looking double. Okay, where they have those. Those are kind of weird looking, aren't they? Well, we always start on the inside. In this one here, the square root of x squared is x. And then this sign here stays there, and that's it for that answer. So that was pretty easy. But let's look at some of these that are a little tricky. When we have something like 75, the cubed root of the fourth root of a. What we're going to do is we're going to change the radicals to exponents. So we're going to change this fourth root of a to the 1/4. Because remember, it means the exact same thing. Then we're going to take the cubed root, which is this one, and change that to 1/3. And then when we multiply this, we get a to the 1 over 12. And then when we switch it back, we get the 12th root of a. So that was one of the reasons I taught you how to do that, is because there are times where that becomes very handy. In fact, let's look at number 79, because that one looks really tricky. We have the fourth root of the cubed root of a to the 12th, b to the 24th, c to the 14th. Okay, we're going to do the exact same thing. We're going to take the inner radical and make it a to the 12th, b to the 24th, come on, 4, c to the 14th, to the 1/3 power, because that's what that tells me. It doesn't look very 24-ish. Then I go to the next one. We'll do that in yellow. Parenthesis to the 1/4. So now I have a to the 12th, b to the 24th, c to the 14, to the 1/12 power. Alright, so as you look at this, what we can do next is we can start putting those together. 12 times 1/12 is 12 over 12. B 24 times 1/12 is 24 over 12. And 14 times 12 is, or 1/12 is 14 over 12. So 12 over 12 is 1. 24 over 12 is 2. And C, if we were to reduce that, that would be 7 over 6. But because the answer is in radical form, let's go ahead and, or the problem is in radical form, let's go ahead and put it in radical form. So these don't have fractions for their exponents, so they're not in radicals. This one does. This is the 6th root of C to the 7th power, right? So how many times does 6 go into 7? One time with 1 left over. So AB squared C times the square root of, or I'm sorry, the 6th root of C. Yeah, my glasses are terrible. And that's what you get. Alright, so look at that one again closely. Because this is important to be able to understand how this works and why it's necessary to switch something like a radical to an exponent. Okay? And then if you reduce that, you have b to the 1/3, and if you change it back to a radical, that gives you the cubed root of b. That is a lot simpler than that is. And all it takes is being able to switch it from a radical to an exponent and then switch that answer back to a radical again. Alright? Anyway, that is 9.3 problem set.